Yeah, okay, thanks. Okay, so now again, we are going to talk this on offensive security now with without AI and now with AI. So me every day, a member of a great team of hackers doing pen testing, red teaming, and cyber threat intelligence, focused on offensive security. So offensive security allows us to analyze how to break through defense in order to find less fallible security methods. This is our core team. We have more members, but this is the core. So for the starting points, this talk is technical through exercise. We are going from Dr. Google to Dr. AI. You know, some years ago when we go to some doctor and they give us medicines, we go to Google and say, okay, what is this? It's for me. And now we take a picture and go to our besties, something like a ChatGPT or Cloud or something like that, and you ask some questions, okay? So AI is a tool, not a replacement. And the question is AI security more important than security in general? Who really cares about security? And how many of you went across writing by hand to a mechanic typewriter, to electric typewriter, and from a calculator to a computer? So think about it. Do you remember the phone number of the 5 most important people to you? So it's a good question. So we are going to see now some difference about hacking. We have pen testing, we have red team operations. So the question is, what else? And these are two frameworks about one is for pen testing and the other is for red teaming. Okay, there are some different steps. So well-known story. Some time ago, when we use something like a Nessus, for example, you know, this is a big button tool. There is button, and all the network is under attack. And I'm such as a hacker. So because it's all automated, you only have the results of the tool. And the pen tester is more like a chef. Okay, we know the specific code, we can modify, we can create something new. So the holy grail is automate, and the automate is no new. This is a post on 2009 for OpenSec, and this is auto-exploitation with Metasploit. Okay, this is something like a brute force with all exploits I have, and maybe one of that exploits are going to be successful. Okay, but what's happening when my other machine is Linux, for example, and I use some exploits from Windows? Okay, so it's not smart, but it's brute force, but it tries to automate that. So AI must be optional, effective, optimal, effective, and efficient to be a real tool for collaboration or replacement of humans through automation. So we have some real cases here. The base of the analysis is soft skills, not included in the analysis, penetration testing. In penetration testing, we have some difference to red team operation and cyber threat intelligence. In penetration testing, is highly controlled. We have a scope. The people of the blue team knows we are going to attack them. So it's driven by regulation or by the market, something like PCI DSS, for example, or something like that, and is periodically. Okay, and in red team operations, we see something in a threat emulation and adversary emulation. We are going to see this later. So in cyber threat intelligence, we have information analysis and attack vectors deployment. So we are going to see now the first case. The first case is a well-known vulnerability with no AI. This is a Lexmark printer, okay? It's not fully configured and it's vulnerable to command injection. This is the CVE, and it uses a small Linux. So the core here is the exploit already exists, okay? But when we see what can we do with that exploit, it's not fully configured, so we don't use that to get something like an Active Directory credential, for example, or something like that. But to execute the exploit, we can use one line on remote code execution. As it is something like we can use commands like who am I, netstat, or something like that. But if we need to do this, we need to do exploit and exploit and exploit and exploit. So what's happening if we do only one command? And say, in that command, you're going to have a reverse shell, for example. So in that moment, you establish, you're going to put a session. Okay, so you can execute other commands in order with no exploit and exploit and exploit. The case two is a server-side request forgery. It's a very common vulnerability with no AI. In this case, we can see the internal infrastructure, for example, and in the middle we have the server. So the attacker is going to do a request here, and there is going to get that direction, and the end of the direction we have another direction. Okay, so the server here is going to retry that request to internal infrastructure, and the result is we are going to have an admin panel, but that is not an admin panel from the middle servers, from the internal infrastructure. This is an internal, this is xmlrpc.php. This is very famous on CMS like WordPress, for example. Okay, here we have something like a very common. If we list the methods, we can do something like a ping back ping, for example, and on the value we can put an internal direction. Okay, so we can try here to scan some ports, but the question is, how can we know if the port is open or closed, for example? And in this particular case, the response is on the time. So time to complete request when a port is open is longer than when closed or filtered. Okay, so it's something like a scan, but in blind mode. Okay. Oh. Okay, I'm going to do this manual, I think. Okay, right. And this is a mix of vulnerabilities. We have here a local file inclusion and remote file inclusion work together. In this case, for example, the attacker is going to send a local file inclusion. Okay, there is going to execute some commands and say, okay, the result of system ID or system info, for example, put that result in the text and give me that text. So I have a local file inclusion because I'm going to put that very bad.txt, and I'm going to execute some commands, and the result is going to put that on the very bad.txt. Let's print gray here and put some buttons. So this is a very interesting vulnerability on Llama. Okay, and here we have the attacker in the number one is going to interact with an API, and in the API is going to interact with the backend. So what's happened here in the backend, you can say, okay, you're going to use this hub or something like, and you need this requirement, but you don't have this. So you need to connect this to other server to try to give that exactly hub. So in this part, this other hub is controlled by the attacker. So in this hub, you can execute your own commands, or you can put your own data. So when the backend is going to process this new hub, there is going to be a remote code execution, for example, and the result is going to bring to the API and then to the attacker. Okay. So the question here is, how could it be with AI? So what about automated detection of these vulnerabilities? And the response here is already automated. Some tool like a Nuclei, for example, this is going to test a lot of CVs. Okay, but you are not going to test CV by CV manually. It's automated. So this is already automated. So what about applying AI in this case? In the first case, it is highly probable because we tried this some weeks ago, and we managed to get a simple bash script to work with just a single user prompt. So the AI can help to do a script to automate that. In the case two, that chain of vulnerabilities is probable because you need to think, if your data set is very small, your training it's going to be okay, but maybe the result is not going to be good. Okay, so you need a big data set in this case. So training can be done using deep reinforcement learning. That's trial and error. So how can it could be with AI? In the case 3 on Llama, this is very complex here because it looks less time to perform the exploit manually than to fine tuning. Okay, and this part of fine tuning is something like a training. Okay, this sounds more like training. So without knowledge of shared libraries, it should have been impossible unless you have time to train the model. So unlikely with only GPT. More likely if we add a RAG, for example, or have some chatbot to search on Google. Okay, so this is the continuation of this. We asked to GPT, okay, that is for arbitrary inclusion file reading, but I want a remote code execution. Okay, so they give us a lot of sources. Okay, but then the response is interesting because we say, okay, but we need some functional, some skeleton or pseudocode in order to start learning, not from zero. And the response is interesting because they say, it says you can start by understanding its underlying mechanism. And this is the core of cybersecurity. You need to know what's happening behind, because if you know the flow, you can alter some part of the flow to give other response. Okay, so we have a red team here, red team operation, and it's important to clarify several aspects. Also, this talk is solely about red team. One thing is threat emulation, if you prefer adversary emulation. So another more complex, advanced, and real is adversary simulation. Okay, we are going to see the difference here. Why is a red team operation carried out? To measure two factors. The blue team needs time to detect and time to mitigate. Okay, this means that not every organization is ready for a red team operation. So in red team operation, we have a threat emulation, can be automated and is commonly automated. And an adversary emulation is automated only when total compromise is obtained. Okay, so in threat emulation is based on frameworks like ATT and CK and Atlas. And adversary simulation is required to attack in an unexpected way by the blue team, and they wait the attack as the framework state. Okay, this is about shadow AI. This is a case. So we have this case a few months ago. Shadow AI is when some part of the company needs to be on production, some services, and they are not going to say that to the Department of IT Technology. Okay, so they only put that because they need that at that moment. In this case, there are people of scientists. They need to put on production at Jupyter, for example, to do some machine learning. But when they deployed here, they deploy this, they can't see something like in a terminal. Okay, this is by default. And when we do that, when we inspect that application, that service, we see a terminal and we think, okay, what's happening if we put do click here, and there is going to generate new terminals. So in the terminal, the first recognition is something like who am I, in the start, and all that. So in that team, we say, okay, and what's happening if we can try sudo su, for example? Is that functional? And in this case, that's functional. When you are a sudo, you are administrator of the system. Okay, so when we get sudo, we have an EC2 user. Okay, and this is a popular user of Amazon, for example. So we can we suppose there is on Amazon. So the next step is, okay, we need a token to interact with the tenant. Okay, so we are going to do some actions here because we have all the data, and we are going to request a temporary token. And in this token, we have an access key ID, secret access key, and the token. And with that token, we use other tools, something like a Pacu, for example, and we can execute commands directly. Here we have the policies, for example, is we have the control of the tenant only for a misconfiguration. Okay, so this is very, very dangerous. We have administrator access, and we can do a lot of things here. Okay, so thesis, postulates, speculations, MCP. Okay, this is the model context protocol. It's something like the evolution of the AI. So this is investigation about Daniel Messer in 2023. Okay, and he tried to explain what is how is the AI functional here. We have agents, we have tools, we have storage, we have models, we have a lot of these things. But MCP, it's we try to explain this by our besties, like Claude, for example. Okay, and it says a lot of things. Gemini, it's complex. Okay, so we do not understand this in the easy mode. Okay, OpenAI, the same. And then we see this on Tenable. Okay, and this is very simple. This is, we have an LLM API, just Gemini, for example. Okay, we have a LLM interface, and there is going to interact with MCP clients. And the difference here between an LLM, it's there is going to there is going to do execution. Okay, there is going to execute something you want. So there is going to search the tools, for example. They are going to see what is the best for you. So in offensive security, we have Kali MCP server, okay? And Kali have a lot of tools for cybersecurity, okay? And it has an API container, has an MCP server. We're going to see this in a little moment. And there is the GitHub. In GitHub is the source code here, or MCP Kali. And there is the configuration. It's a fast MCP. Okay, if we can see here, we have a local host on that port on 5000 because there is going to interact with the API. Okay, and we have the MCP server with other functions. And in one part, we are going to execute some commands. Here, for example, we have the API tools, nmap, and the method post is going to receive the data, and there is going to execute some command. Okay, over there, we can see the execute command here. Okay, so I'm going to show you a short video here about we test this. Okay. Okay, so here the idea is very simple. This is a metasploitable. It's a machine with a lot of vulnerabilities only for test this. Okay, so we are going to interact with the MCP server, and we are going to see what's happening with the LLM. This is a Kali with the MCP server running in other machine, and we have other machine. This is in a Windows machine. Okay, this is a Windows with Visual Studio Code. Okay, it has a plugin of root code to interact with the MCP server in Kali. And we are going to say something like, okay, can you scan the 3,000 most common ports and tell me in detail what services are running? After that, I also want to know if any of those services have known vulnerabilities, the target is and the IP direction, okay? And that's all. And when we execute that, this is the configuration on the MCP, okay? So there is going to go. This works with Gemini. I put my API key on Gemini, and there is going to interact to interpret me, and then is going to interact with the MCP server. So there need the tools of MCP server and say, okay, we have the tool on nmap, for example. Okay, so I'm going to use nmap to scan ports and to search some vulnerabilities on that port. Okay. Okay, so this is the request. Okay, nmap scan is the tool on Kali. Okay, so there is. I'm going to approve here, and you can automate this because there is only for precaution here. Okay, so then if we see here, they have the results of the scan, and then say, okay, I need to search some exploit. So in this case, there is going to use search exploit on the service it found. Okay, so I'm going to put this faster. Only to see the results here, please. Okay, this is the result. Okay, and the results say, okay, the ML task is completed. Okay, we have these tools open in that port, and this is some vulnerabilities. Okay, we find, for example, in that number 21, that is FTP with that version of software, and no vulnerabilities. We found a critical, that's a backdoor command execution, and that's the CV. Okay, so all that we have only with a prompt. So the magic here is the user is only going to interact with a prompt. The prompt is going to connect to the MCP server, and the MCP server is going to execute some action. Okay, so in this case, it's for offensive security, so we can see the ports, we can see vulnerabilities, and maybe we can say, okay, now exploit that vulnerabilities. Okay. 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 Give me a second, please. Okay, so In a company, we have a Pentester 1 NG. This is our MCP implementation. And it's very easy to use because we only need the target and what type of scan we are going to do, one type of pen test. In this case, for example, we enter the IP direction here, okay, and we select what type of pen test. In this case, we have an infrastructure, for example, and this is the type of fast because we don't, this is only for this test. Okay, and the result is something like this. Okay, so the tool is going to interact, it's going to connect to the MCP server, and there is going to give us some results, something like critical vulnerabilities. Okay, and this is the CVSS. And then we are going, we have some graphics here about the risk. Okay. Oh, sorry. Okay. 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 So for the conclusions, keep looking for using. Sorry, I'm going to move this. Okay, so on the conclusion, keep looking for using AI and all its acronyms and how it could help offensive security. So test by yourself, keep breaking everything related to AI. Gandalf, for example, is a good starting point for doing an AI interaction. Of course, we don't try to reinvent the wheel every day. We need to know how ping works, for example, but we don't have to make our own pings. So we use that one included on the operation system. This also applies for AI. Learn about the models, learn about the algorithms that support the models, develop your own code to test the models, and develop an attack vector. Okay, so the postulate says you can spend your life asking ChatGPT or Cloud or Gemini or whatever, but it won't make you a hacker. So you can wait for the magic tool AI powered and use it, but it is still doesn't make you hacker, not nor pen tester. Prompt injection is very useful, but as of today, it's just a small part of the AI security. Actually, developing an offensive security mindset is that allow you to turn into hacker and then pen tester and maybe a red teamer. So understanding how your target works is what prevents you from being an AI kitty. Okay, so I think that's all.